Hello everyone, I am Professor Tiwari. This video is based on request from some of our subscribers who are preparing for the ACT test this summer. It is the first in a new series with more coming soon. In this particular lecture, I will do a quick and focused review of basic shapes and their properties, especially tailored for the ACT exam. Let us start with some basics. A straight line measures exactly 180 degrees. Complementary angles are the two angles that add up to 90 degrees. You can think of a right angle split into two parts. Supplementary angles go a step further. Their sum is 180 degrees, forming a straight line. And then comes vertical angles, which are formed when two lines intersect. They sit opposite to each other and are always equal. So now let us look into these figures. The first figure which I have shown here explains complementary angles. So you can see there are two angles. One is here, which is 60 degree, and then second is here 30 degree. If you add these two up, they become 90 degree. So these two angles 30 and 60 are called complementary angles. Now let us look at the second figure, which has again two angles. One is 40 degree, another is 140 degree. If you add these two, they become 180. So they are called supplementary angles. And the figure here shows what are the vertical angles. If you have two lines which are intersecting, so number one line is here, number two is here, then you see there are some angles are formed. And here the property of this angle is this top one angle here and this bottom angle here, they will be exactly equal. Similarly, the angle on this side and angle on this side, they are equal. So this is the property of vertical angles. So in ACT test, they may give you some of these figures and may define one angle and may ask for the other one. Okay, so you should be able to solve that question very easily. Now coming to triangles. So first of all, you should always remember that the sum of interior angles in any triangle is 180 degree. So there is no matter what kind of triangle is, that sum will be 180 degree. Then for the purpose of doing good in ACT test, you should have some special knowledge about these three different kinds of triangles, which are called right angle, which is shown here. It has one angle which is 90. So in a triangle, if you find one angle 90, we call it a right triangle. Then comes a triangle known as isosceles triangle. Isosceles triangles are such that two sides are equal and their respective angles are also equal. For example, in this figure, angle D and angle F are equal, and the side opposite to D, which is this one, and side opposite to F, which is this one, these two sides are also equal. So this kind of triangle is called isosceles triangle. Now coming to third important kind of triangles, which are called equilateral triangle. In this kind of triangles, all sides are equal and the respective angles are equal, and each of those angles is 60 degree. So in the exam, they may give you two angles and may ask for the third angle, or may ask what kind of triangle is this. Then by looking into the figure, you will have to tell that thing. And of course, you should not forget the famous Pythagorean theorem for right triangles, which says a square plus b square equal to c square, where c is hypotenuse, which is shown here in this triangle, and a and b can be any of these two sides. So a square equal to b square, a square plus b square equal to c square. So they may give you two sides and may ask for the third one. So you should be able to do it very quickly without any problem. Let us now look at quadrilaterals and polygons. First, remember any quadrilateral, meaning any four-sided figure, has a total interior angle sum of 360 degrees. So, this will be true for any kind of quadrilateral system. Now, let us go through the most common type. So, there are four common types, and all of us are very familiar with square and rectangle. A square has all sides equal and all angles are exactly 90 degrees. And in a rectangle, there are opposite sides which are equal and all angles are 90 degrees. A parallelogram, which I have shown here, which is little bit less common than square and rectangles. In a parallelogram, they have opposite sides that are equal and parallel, but angles are not 90 degrees. You have these two sides which are parallel and equal. These two are also parallel and equal, but angles are not 90 degrees. So, they are called parallelogram. And then comes a trapezoid, which has only one pair of opposite sides that are parallel. So, only one pair, which is shown here, is parallel, and the other pair, which is here, is not parallel. So, these are the four common quadrilaterals, which many times in ACT tests they ask questions based on these kind of quadrilaterals. Now, moving on to polygons. If a shape has n sides, n number of sides, then the sum of its interior angle is given by the formula n by n minus 2 multiplied by 180. So, polygons may have any number of sides, and then if you have to find how much is the sum of interior angles, you have to use this formula. For example, a hexagon which has 6 sides will have a total angle of 4 times 180, that is 720 degrees. So, in the test they may give a particular value of n and say find how much is total interior angle, or they can ask this question in other way around also. But if you remember this formula, you should be able to do it very quickly. Now, let us move on to circles. As all of us know, the diameter is the full length across the circle through the center. The radius is the half of the diameter. The circumference is given by the formula 2 pi times r or pi times d. The area of the circle is given by pi r square. And now, let us come to arc length. Suppose they have given this circle, then AB, which is shown here, suppose this is a arc, then the arc length is equal to the angle theta divided by 360 multiplied by circumference. So, in some of the questions they may give you this angle theta and probably radius and may ask for how much is this arc. Okay, so, you should be able to do it by simply using this formula for arc. Sector area. In this here, what you are seeing in this circle, they have made this angle, this theta, and they may ask how much is the area of this sector. So, again the formula for sector area is theta, the angle which this sector is making, divided by 360 multiplied by pi r square. So, by using any of these simple formulas, you should be able to answer most of the questions related to circles. Now, let us move on to area and perimeter of common 2D shapes, something that shows up a lot on the ACT. We start with the rectangle. You need the length and width to find both its perimeter as well as area. So, if you know the length and width, you can find the perimeter, which will be 2 times the sum of length and width, and area will be length times width. Very simple formula. For a square, all sides are equal, which makes both of these formulas is still nicer and simple. Because length and width both are equal to S, the area will be 4 times S and perimeter will be 4 times S and area will be S square. So, and these are very simple formulas. Next we have the triangle. To find the perimeter, just add all 3 sides here A, B, C, and that is the perimeter of a triangle. And for finding the area, you need the base and the perpendicular height. If you have to find area, you find the base of the triangle and the height, and use simple formula area equal to half times base plus height. Now coming to parallelogram. The parallelogram may look like a pushed over rectangle. You have a rectangle, you just push it, it will become a parallelogram. But this area is still just the base times the height. But remember, the height must be measured at right angle to the base. So this height which is here, you have to draw a start from here perpendicular to this side. So that is the height. And after that, just you multiply base and height, you get the area of the parallelogram. Now finally coming to the trapezoid. This one is slightly trickier because it uses both parallel sides which are called often bases and the height. So here you are seeing this side and this side, they are not equal although they are parallel. Let us say this is B1 and this one is B2 and height, perpendicular height is h, then area will be given by this formula B1 plus B2 divided by 2 multiplied by h. So it is helpful to memorize this one for this trapezoid carefully because it is a bit different than rectangle and square and triangle areas, and because it doesn't come up as often, but it is easy to miss. So if in the ACT test this question comes and if you remember this formula, you will do it correctly. Now let us look at the 3-dimensional shapes starting with the prisms and cylinders. For a rectangular prism, the volume is just the product of height, length and width. So it is a simple formula, length times width times height is the volume. To find the surface area, we calculate the area of all 6 faces and then add them up. The surface area will be 2 times length times width, length times height and width times height, and you just add all these things together, you get the total surface area of a rectangular prism. Next up is the cylinder. Its volume depends on the base of the cylinder here, which in this case is a circle. So we have to use the area of this base as pi r square multiplied by the height h. The area of a cylinder is pi r square, means the area of the base multiplied by height, and that is the volume of cylinder. For surface area, we have to break this into 2 parts. There are 2 kinds of areas. The first one is lateral surface area, which wraps around the sides like a label on a can. Suppose this is a cylinder, this is a can, and you label, cover it with some label from all around. So that is called lateral surface area, and that is given as 2 pi r h. But the total surface area also includes circular ends from this side and the bottom side, both circular ends. So the total surface area comes out to be 2 times pi r square plus 2 pi r h. So be very careful whether they are asking for lateral surface area or total surface area. If they ask for total surface area, you have to find the sum of lateral surface area and the area of the top and bottom bases. Okay, let us talk about pyramids and cones now. Both are the tapering shapes with pointed tops like here, and this tapering surface. We will start with the right pyramid. In this case, if the base is a square, the volume is given as 1/3 of the base area multiplied by the height. And this 1/3 comes because the pyramid narrows as it rises, unlike a prism. In the case of prism, we saw in the last slide, there was no 1/3. But here, because in the case of pyramids, they are narrowing up when it is going up, which brings this factor of 1/3. Next, we will look into the cones, which is like a circular pyramid. So its formula is, volume formula is similar, 1/3 times the base area times the height. But in this case, because base is circular, so we have pi r square for base area. Now coming to surface areas, the cone has two parts. The first one is the lateral surface area, which wraps around the side, and then the total surface area, which includes this lateral area along with the area of this base, circular base. Okay, so by just putting numbers in these formulas, you can find out both lateral surface area, which is given as pi r times L, where L is called the slant height. Here you need to be a little bit careful when calculating the lateral surface, because it uses the slant height L, pi r times L, not this h. Okay, sometimes students get tripped up here. Okay, so you have to be careful that when you are using lateral surface area formula, you have to use this slant height L. So remember this formula very well. You have very good chances of making mistakes here. Total surface area is pi r square plus pi r L. Okay, this L, not the h, because that is something which people can get confused. Okay, I think with this formula, if you remember all these, you should be able to find all these areas, volume, etc. correctly. And finally, we wrap up with the spheres. A perfectly round 3D object like a basketball or a planet. To calculate its volume, we use a very simple formula, which is V equal to 4 pi by 3 pi r cube, and the surface area, which measures the total area of the outer shell, the curved surface that wraps around the sphere, is given by 4 pi r square. Okay, volume is 4 pi by 3 pi r cube, and surface area is 4 pi r square. So these formulas are not usually something you can guess. So it is helpful to remember them or recognize them quickly when given as answer choices. I hope you found this session useful and time efficient. More videos are coming soon, so stay tuned. Keep practicing, and don't forget to subscribe this channel if you have not done already. See you in the next one.